Math 3, Unit 9, Logarithm Rules Activity. This activity should be completed after you finished Section 4, but before you go on to Section 5. So, we have some logarithms here, and we are going to evaluate the expressions based on what we know so far. So, like, when we get a logarithm base 2 of 8, that means what power do I raise 2 to get 8? We're going to actually find the values there of each piece and then add them together. And then part 2, we're going to be subtracting, so it's similar. All right, so what power do I raise 2 to get 8? So in other words, 2 to what power gives me 8? 2 to the third power is 8, so that's 3. 2 to what power gives you 4? That's 2. So in this case, we're doing 3 plus 2, which gives you 5. We're going to do that for all of these, 1 through 4. 3 to what power gives you 27? You should have said 3. 3 to what power gives you 3? That's a 1. And 3 plus 1 is 4. 4 to what power gives you 4? That's 1. 4 to what power gives you 16? 4 squared is 16. And 1 plus 2 is 3. 5 to what power gives you 5? That's 5 to the first power. 5 to what power gives you 0? That's 5 to the 0 power. And 1 plus 0 is 1. All right, so that was just part of each question. Let's try to determine what other value gives us 5. So when we say 2 to what power gives you this answer, we want to find a statement that has the same exponent as what we got over here. So this still needs to be equal to 5 when we find our answer. In other words, this would be in exponential form, 2 to the 5th power equals, well, 2 to the 5th is 32. So the number that should go inside the parentheses here is 32, because if I said 2 to what power gives you 32, you would tell me 5, just like these logs are equivalent to 5 as well, after adding them together. All right, let's try another one. So this logarithm, we want the exponent to be 4, so the log is going to be equal to 4. If I'm saying 3 to what exponent gives me this blank, I'm saying 3 to the 4th power gives me the answer of 81. So that's 81. 3 to the 4th power gives me 81. If I want this logarithm to be equal to 3, I'm doing 4 to the 3rd power. So 4 times 4 is 16. And 16 times 4 it's 64. All right. And then I want this answer to be 1, so 5 to the 1st power is going to give me 5. All right, so number 5. What pattern seems to hold? Write a rule. So we have log base b of x plus log base b of y. Let's take a look at the left-hand side of that equation. The logs are the same, the bases are the same, but the x and y are different. So as long as you have the same base, what do we do with the x and y to get our new answer? So log base 2 of 8 plus log base 2 of 4 equals log base 2 of 32. What do you do with the 8 and the 4 to get 32? You multiply them. What do you do with 27 and 3 to get 81? You multiply them. 4 times 16 is 64, and 5 times 1 is 5. So you should be multiplying x times y. This x times this y. Use the new rule to solve some problems that were impossible before. So first of all, if I would have asked you 6 to what power gives you 12? Well, you could say something between 1 and 2, but I'm not sure what it is. Because 6 to the first is 6, and 6 squared is 36. 12 ends up between those two. If I use my rule, I'm going to be able to solve for an exact value here. So, if you're adding two logs that have the same base, then you multiply the answers together. So 12 times 3. And this gives me log base 6 of 12 times 3 is 36. Now I can solve this. So log base 6, this is 6 to what power gives me 36? My answer is 2. Okay, this next one, they're both not, the base is not written down, so that's log base 10. All right, so I'm going to do log base 10. 250 times 40, well, we know 25 times 4 is 100. So 250 times 40 would be 10,000. So 10 to what power gives you 10,000? 10 to the 4th power. That's a 4. All right, next one. We have log base 8. And we're going to multiply 3 over 64 times 1/3. Just remembering that if you have a 3 in your numerator and a 3 in your denominator, those are going to reduce. So you're going to get 1 over 64 here. So I'm going to do log base 8 of 1 over 64, which is the same as log base 8 of 1 over 8 squared. So you should know that this is in the denominator. So x to what power gives you 1 over, 8 to what power gives you 1 over 8 squared? That should be a negative 2. All right, so what you're going to do is what we did in part 1, but you're going to finish it for the rest of the assignment. So part 2 is just subtraction. You're going to figure out what 5 to what power gives you 125, 5 to what power gives you 5, and then you're going to subtract them. Remember, that value tells you your exponent. So when you are figuring out what should go in the blank inside here, you should be raising 5 to the 2nd power in order to get whatever goes inside the blank, which in this case would be 25. Okay. And you should get matching values. We can already take a look at what's going to happen here. How do I take 125 and 5 to get 25? You're going to end up dividing them. So it's going to be x over y. But I want you to go through all of part 2. I want you to go through all of part 3. Part 3 is a little different, so we'll do an example together. And then you will also do part 4 on your own. So, part 3, we're doing something similar, but you'll notice that something's being multiplied in front of our answer here. So let's try this out. So log base 2 of 4 to the 3rd power. Let's talk about 4 to the 3rd power first. 4 to the 3rd power is 4 times 4 times 4, which is 64. So this is saying 2 to what power gives you 64? And in case you didn't know, that is 2 to the 6th power. So this is 6. Which is the same as, remember we set this equal to 6. Well, log base 2 of 4 means 2 to what power gives you 4? 2 squared gives you 4. So what do you multiply by 2 to give you 6? Well, you multiply 3 times 2 to give you 6. All right, same thing with this next one. This is the same as log base 3 of 81, because 9 squared is 81. 3 to what power gives you 81? 3 to the 4th power gives you 81. So this has to be equal to 4. Well, over here, 3 to what power gives you 9? 3 squared gives you 9. So what are we going to multiply by 2 to give me 4? We're going to multiply 2 times 2 to give me 4. So you'll notice that the exponent is being multiplied out to the front here. Okay, go ahead and finish that. But let's go ahead and fill in the pattern here. Log base b of x to the c is going to end up being c times log base b of x. Okay, so when you're setting up these new examples, you're going to take your exponent and you're going to multiply it out to the front. But don't forget to evaluate the logarithm after that. Log 3 of 9 is 3 to what power gives us 9? That's at 2. So you're going to multiply 250 times 2, which gives us 500. Okay, don't forget to finish the rest of those. And then combining these rules together, this is stated on the previous slide. Log base b of x times y is the same as log base b of x plus log base b of y, and then it has the reverse. Log base b of x plus log base b of y equals log base b of x times y. So same statement written the other way around. So you could go, it's just telling you you could expand or you could condense into one logarithm. So if you notice here, we have one logarithm, we're expanding them into 2. Over here we have 2 logarithms, we're condensing them into 1. So it helps us on solving different problems by expanding and condensing. And then you're going to finish part 4 and the rest of the ones to fill in on your own.